Good morning, everyone. My name is Michael Schmela. I'm the Executive Advisor at Solar Power Europe, the Association of the European Solar Sector. And I'm very excited to talk this morning about the really big, the very high power modules, the latest the industry has, with leaders from the solar sector. This panel takes place as part of Intersolar, the largest European solar show. And if you're here, just pop by to any of the booths of our distinguished speakers and their companies. We have with us today Gao from Trina Solar, where he's the head of global product management. I'm also happy to welcome Marius Kaiser, who's the Director, Technical Department and Product Management, EMEA at Canadian Solar. And we have with us Yifeng or Danny Song from Ryzen Energy, who's the Director of Product Management. So a lot of expertise. If you have any questions, you can also go to LinkedIn at Trina Solar, at YouTube, or any other social media channels. Leave questions there, and the Trina team will be there to answer everything, hopefully everything you need and want to know. Okay, let's start. 210 is the new big number in solar, the biggest number for the moment, at least. So this journey has started actually just very recently. I think there was a time ago, some time ago, a decade ago, when we already had 8-inch wafers, but that was a try actually, and then it disappeared for a while, and then it popped up and it came massively. So 210 is the biggest you can get. And let's just discuss how Canadian Ryzen and Trina, who have been all leaders and in this field, pioneering and pushing that technology, how they have adopted that technology. So maybe let's start with Lee, and just let me know actually how Trina came upon 210 and what convinced you to move massively into that technology.
Yeah, thank you, Michael. And we believe the cost value is the main driver for the 210 technology, and which makes us lead this technology and introduce it into the industry. The first word popped up in my mind is collaboration. By collaboration with partners along the customer value chain for such kind of innovation. For example, the ingot, the wafer, we have Zhonghuan in the wafer side, and they just claimed that they will parallelize the 210 wafer at the first place, especially in such at this moment, such kind of tight supply chain situation. And we also have collaboration with the inverter, cell, modules, EPCs, trackers like Huawei, Sangro, SMA, and Goodway, Next Tracker. Okay, it's a long name list. And they all claimed that the new product already compatible with our 210. I think we can say it's a base to make sure our 210 technology can be driven faster. And as you can see now, we have a lot of clients already signed the contract with our 210. We can call 600-watt alliance partners. Okay, Michael.
Okay, thanks. Let's actually have everyone in this round simply state at the beginning the motivation. So Marius, why did Canadian Solar go to 10?
I would say at first it's important to know that we come from a more or less standardized world, right? So when I started 10 years ago, there was one module type. It was a 6-inch cell, 5-inch didn't exist anymore. And this prevailed for a pretty long time, actually. But then there was a disruption. So we had 166, 166 plus, and eventually modules got bigger. And I think every time we improved our modules and improved the technology, it was always driven by LCOE. That is the main driver, right? So we are, and this is, again, this is also driven by LCOE. So coming from a standardized world, of course, big manufacturers want to have a standardized module, right? And we see right now a very fast adoption. This is something I think that proves us that we are on the right track. So as Gao said, we have a lot of manufacturers and partners already having compatible products. So we have inverters, we have the systems ready. So we think there is already an acceptance in the market. This is what we see. And again, it's all driven by LCOE.
Okay, Danny, what was your driver?
Okay. Okay, firstly, I think for this question, I think we need to make one point clearly. Which point? What is actually demand and the requirement from the customer? Because from my point of view, our customer request is not to the wafer size. I mean that our customers, what they want is not the 166, is not 158.75. Not 182, I think even not 210. What they request actually is the lowest LCOE and the lowest EOS. This is what they requested. But for Ryzen, I think also for Trina and also for CSI, I think everybody also mentioned one very, very important word, the LCOE. Because the 210 for this wafer, for this size wafer and the cell and the module, this product can take the lowest LCOE. So I think this is the driving, and this is the only one reason that the 210 modules for this series product can be very popular and hot in the market at this moment. I think this is the root cause that we can found that the 210 modules come to be more and more popular. So this is my point.
Cool. Okay, so then let's talk cost, which is also an important topic at a time when prices unfortunately are going up due to the silicon shortage, which is all out of our hands, but it is as it is. And maybe some other things like a general product shortage, transport shortages, and many things. But let's talk LCOE. So how actually, or what's the reason 210 is actually superior to many other technologies when we talk in terms of LCOE. So what has brought the industry to go for very high wafers, which are actually pretty thick? So those people who are not pretty thick, pretty big, but so who don't know them. So if you would see that and you're not in solar, you would think, wow, I think that would mean more breakage, more difficult handling and cell production. And nevertheless, actually, the LCOE is lower, could be improved over previous generations. So who would take that, Lee?
Yeah, I can say something about the pure numbers. So if we would compare, for example, let's take a 30 megawatt site, because I asked about numbers, 30 megawatt site, and you compare a currently available module, 440, 445 watts, based on a 166 cell wafer, and you compare it to the, say, the high-end 660 watt plus module that we have available right now, which is based on a 210 wafer. on this side, the huge benefit is that we operate at a pretty high voltage, 45 volts in this case. But don't quote me on a number, but right around that, in that ballpark, 45 volts. Right? So benefit is we can have longer strings. We have strings of 30 up to 32 modules, depending, of course, on the area where you are. So a longer string means you have a very high power per string. We reach over 20 kilowatt per string. And this in turn means that you have fewer cables. So your EBOS goes down on the system. You have you need fewer DC combiners, fewer cables, fewer DC components, and of course the labor costs. So we talk around, and again, LCOE is always highly subjective to the site where you are. So these numbers, if you're listening, they don't have to match your specific site. If you're interested in this, you know how to contact us. We can help you with LCOE calculations for your specific site as well. We have a team for this. But it's around a ballpark of like 8% that you can save on the components, EBOS wise, and 30% or more, again, depending on the region, wages, so labor costs, etc., on your physical labor for the EBOS. So all of this means by improving or actually decreasing the number of strings by around 35% in my 30 megawatt example, and having more power per string, around 60% compared to a 445 watt module, these are significant savings. And this is the LCOE saving that is driving and is basically driving the acceptance of the 210 based modules.
Anyone wants to add on that?
We also make some investigation and calculation and simulation for the different modules. And for us, we also take not only the electrical point, but we also make some calculation regarding the mounting structure. And as what we calculated, for example, we calculated the fixed structure and also the single axis tracker, and we found that compared with the old module, I mean that compared with the 166 module, and we can for the all the amount of the structure and also the pole and also the cable length, and there are much saving of this compared with the 166 module. I think for the mounting of the structure, and if we compare with the 160 watt modules, and it can save about 15% of the mounting structure amount. So it's only at this point we can also save a lot of cost of the whole structure and the whole PV system.
Okay. Lei, maybe we can actually also go into or look at it from cell and module production. So if you look at that, so are there also savings possible on that side, and where are the savings that contribute to the final LCOE?
Yeah, from Trina point of view, of course, the 210 technology will bring the benefit to our partners. But meanwhile, I think it's more important is it will bring more benefit to our customer. Let me make an example: the transportation cost. You know, the transportation cost currently is going up very high and very fast. And if you compare of the 600 watt plus modules, like the 600, 670 watt module, you will find out that our packaging design is quite optimized, and it will have a higher capacity than the conventional module. It's around 12%. And we have made a rough calculation that the higher capacity in the container, it will bring the customer around 0.3 to 0.5 cent US dollar per watt cost saving. So we believe that will significantly reduce the initial total initial cost for our customer. That is very big, very important point I want to mention here. And meanwhile, you may notice that from Hofer ISE, they had published a study on the new generation high power module BOS and LOE saving part. Okay, and I had made some study on this report. Okay, it shows that there's two cases. One case in Spain, it's a tracker bifacial scenario, and it shows that the G12, that means 210, and M10 module, that's 182, all shows better LCOE and the BOS cost compared with conventional M6. Okay, and compare with the one the M6 module, the capex saving can up to 0.9 to 2.8 cent euro per watt. So that's a very big saving, and LCOE saving can up to 8% for bifacial and the tracker scenario. And I noticed that they also published a study in Germany. It's a monofacial with fixed tracker landscape installation. And compare with the conventional modules, the capex saving can up to 2.3 to 3.7 Europe cent per watt. So we believe that is a good saving, and the LCOE saving is also up to 6%. So I'd like to see for the 210, 600 plus modules, no matter it comes from Trina, from Ryzen, or from Trina Solar, it's all scenario benefit product. It can fit for the tracker application bifacial, and it also can fit for the fixed tilt rack application, especially for the landscape. Because for the tracker application, if you find that our 670 module, which is long, wider, so it's quite a good fit for the tracker. And for the landscape, we found that the 600 and the 670 module, which is wider. So if you mount it on landscape, so it can save quite a lot of tracker. And yeah, that's very good benefit for our customer. And if you are in China, you may notice that more and more players, the module manufacturers, they have did some calculation simulation, as mentioned by Daniel, and they also found the 210 600 plus module is quite customer value, quite a good customer value, and they are joining the 600 watt club. Yeah, Michael.
Okay, thanks. So then let's maybe talk a little bit also about reliability. I think as we all know, I think the change took place quite quickly, and you would say not everything's golden what shines as it is. Where are the challenges that we are meeting? Because first in production, you had to change machinery to be able to do that. You had to, in order to manage this transport and optimize the transport, you had to actually change packaging. The modules are bigger, installers have to also handle it differently. So maybe we can go through the whole value chain and see where the challenges were or are, and how they have been addressed by you. So maybe Marius, you want to go first?
In terms of reliability, I mean, always, if there's something new, it needs adoption. And so I think this has been the case always. And I remember back in the day when Trina Solar launched a dual glass module, it was already known from First Solar back then, but some companies or installers had bad experience with glass breakage and so on. But what we found when we launched our line of frameless dual glass modules, that there were a lot of companies in the market, a lot of installation companies who had experience. So in our in what we found out back then is that it just needs proper training. You need to adopt to the new product, to the new technology, and then it's actually not an issue. You might need somebody who is it's called a skilled labor, who teaches the others how to handle it, but then it's not an issue. So with a very large scale model that we talk about right now, 2.4 meters by 1 something meters. So it's a large scale module where installers would maybe mishandle the module just because they could, because it was a small light module. They would carry it alone, maybe on their head, maybe dragging it by the strings. You physically cannot do this anymore with the large scale module. So you need, as it was instructed all the time, you need two people to handle, to install the module. We predict that the installation quality will even go up now because it's physically impossible to mishandle the module. So in terms of reliability of the power plant and quality, I would predict actually an increase of reliability and quality of the plants that are being built.
Okay. What are you seeing, Danny, in terms of challenges, and how are you dealing with them?
Modules are already very big compared with conventional modules. So I think there are most challenge in the production and also in the beginning of the design of this product. Firstly, I think to increase the structure strength, we have already made a lot of investigation regarding the redesign of our frame. So this is also one point to ensure the whole structure strength. And another is that, I think that maybe in the past time, if you take the presentation from Trina or from Trina Solar, you can also see that we have already used a new technology we call NDS. It's a non-destructive slicing, because all the product we produce now is with a half cell, so we need to cut the cell. But in the past time, and I think there are some potential risk. Micro crack in the cutting edge of the cell. So at this moment, when we use the big cell, I think this risk will be more and more critical. So at this moment, we are ready to switch our our device or equipment to use the new NDS structure device to make the cell slicing. So it can, from one point that I think that when we use NDS, it can ensure that there's no internal stress on the cell edge after slicing. So it can also one very major point to ensure there's no micro crack in the soldering process and in the future using in outside. So another issue, I think that we have already made a lot of extremely tests for our modules, not only the one IEC, but also the 3 times IEC to ensure and make the evaluation of the whole product if it can if there is any risk used in future to ensure that reliability of the product. So this is some point from my side.
Okay, then let's maybe talk also or move a little bit beyond the module, which is of course part of a bigger orchestra of several instruments in a system. So what were the challenges or are the challenges that need to be overcome when we look at the whole systems, when we talk about inverters, when we talk about mounting or trackers? So what are we seeing here, Gao?
What I can see from the system point of view, the challenge will be majorly comes from 2 parts. One part is the inverter. So some string inverters, the old designs, they still have lower current, and the new generation is on the way. Okay, and the second part is, as Marius just mentioned, the application part, because the operators, designers, they get used to smaller size modules, the conventional ones. So they have to adopt to the new modules. So here we are here trying the best to deliver as much information as we can to help our customers to adopt to this new technology. And I would like to go back a little bit to the reliability topic you just asked. Okay, as Marius just mentioned, the standardize. I want to see for the reliability point of view, over 600 aliens, it's just like open source, open source society, like the software part. I'm very glad that we have the world-class companies like Ryzen, like Canadian Solar. We are working all together. And as Daniel just mentioned, we have a new technical design on the frame. I would like to see the design is very important for everyone. Let me make a very easy example. If you have iron, it will sink into the water, right? But if you make it into a ship, it can sail on the ocean. So the design is so important. And we are like Canadian Solar, like Ryzen, Trina, we are all technical driven companies. And we are not only designed the frame, a better frame, but we also conducted several different kinds of tests, and we work very close together and verified. First, we believe we have designed a very good product, and secondly, we have conducted some special additional, very strict verification tests. So that makes sure that our product is tested before shipped to the customer. That's very important information I want to deliver here.
Okay, can you just explain a little bit more about the group of companies that is participating in this 600 watt plus initiative? So who's actually all participating there? As I understand, there are also inverter companies, there are tracker companies, it's a real big group. So how does it work? How are you working to improve standardization and reliability?
Okay, the group, we call it 600 Innovation Aliens. So now we have Trina, Canadian Solar, Ryzen, and like JA, and inverter company like Huawei, Sungrow, a tracker company like Next Tracker, and many other upstream suppliers and downstream customers in this alliance. And currently, we have total 84 partners in this alliance. And for example, in the standardization, I think Marius can talk more about here. The Canadian Solar is somehow leading the size of our frame of the module, and we worked very close together to define the wafer size, and the second step define the module size. That's how we are really convinced of a customer. They do not need to adopt to many different size. In the past, they have to adopt different 166 modules, someone from 1, another from B, but they have different size. For 210, it will be the same size. And we have already done this last year. Last November, we already announced that.
Okay. Anyone?
Yeah, I think it will be very good for the whole industry and for the whole value chain, because we don't, for our customers, they can select the modules from every supplier, and from our supplier, for example, the glass supplier, they don't need to produce different type for the same product. They only can produce one type, one size. That's enough, and it can decrease the waste of the whole industry. And I think for this innovation alien, it's not a closed alien. This is open alien. It means that we welcome every company in the industry, in the chain, industry to join us, because our purpose is to supply the lowest and the best product, and the best product which can take the lowest LCOE to the how to say, to the society, to the whole world. It's not a closed small alien. This is open alien. We welcome everyone that's in the industry chain and join us and contribute themselves to the whole industry.
Okay, maybe just come as a final part, I would like to discuss a little bit of applications. So I think if you think about big wafers, you think about initially about big power plants, but obviously the wafers are also, or the cells later on are cut, and you can also do smaller high power modules and bigger high power modules. Can we just talk about applications for 210? Maybe Trina first, because I believe you are changing completely already, or almost completely, to 210 today, if I remember correctly.
Yeah, we have a full Vertex product family, which can be applied for rooftop application. We call it Vertex S. The power bin is 400 watt and a small size, so it's quite good designed for the rooftops, like the residential, like the industry and the commercial rooftops. And we also have 500 watt module. Okay, for 500 watt module, and the size is slightly bigger than the 400, and it can also be used for the rooftops, especially for industry and for the commercial rooftops, and some of the ground mounting power plants. And our family, if you go up, we have half cut modules, which is 550 watt module, 600 watt module, and the 670 module, which is designed for the utility scale power plants. That's our product family for the 210 technology. All of them is, we call it Vertex family.
Okay, yep. Marius?
Yeah, I would say we are in general in a transition phase, right? So standardization doesn't come overnight, I would say. So important for us is that we lay the groundstone of this 210 millimeter platform, and on this we can build. So naturally, because in a household, you're not that much LCOE driven, right? LCOE driven companies, they act in the utility scale segment. So this is where we started first. So this is why our 210 millimeter based modules are to be found right now, especially in utility scale. However, on this, with this learning curve, and this is important for us because nobody does as much bankability tests and is that thorough as the utility sector. As you know, they have these very long sales cycles. You talk to a lot of technical advisors. You have a lot of institutes who vet your new technology. So I think for us, also in hindsight, this was the right move to go to utility scale first, because here you see the full power of low LCOE, and we will continue to build on this 210 millimeter platform and go further downstream.
Okay, Danny?
Okay, for Ryzen, it is the same. The 210 millimeter wafer is a big wafer, but it doesn't mean that we can only produce the big modules with the big size wafer. We can produce all the size of the modules, and can be applied in the whole scenario. The residential, we have the product, the Titan S. And we can also have the IC scenario with the 550 watts modules. And we can also have a big size modules. I mean, the modules which output is more than 1,600 watts, 1,660. I think only with the 210 wafers, and we can produce I mean, the whole industry can produce the modules which more than 600 watts. And this is a P-type. And in future, Ryzen will also produce the modules with N-type, but also with the 210mm wafer platform, like what the Trina Solar, the Marius said. So the 210mm wafer is only a platform. We can use this platform to produce the P-type PERC modules and also the N-type modules. For Ryzen, we call the Newton series. I think it will be the maximum output will be around 700 watts. I think it will be launched next year. Michael.
Okay, thanks. I think coming to an end, I'm very happy about this panel. I believe I learned again a lot. My conclusion is the industry is growing, and with the growth of the industry, also the power and the innovation of the solar industry continues to grow and to develop. And I think, as we just heard from the panelists and pioneers in the field of 210 wafer size modules, Trina, Canadian, and Ryzen, that's the way to go. If you want to decrease LCOE, I think the higher performance, higher power modules are a very good means to achieve that and bring solar one step further. So while solar is already today the fastest growing power source in many regions, also the lowest cost power source, if we look at the big picture, the contribution in terms of electricity we are contributing at the solar sector is still small. So we have to keep pushing innovation in order to speed up that we tap that we really reach the untapped potential, also in the sake for climate change. Thanks to everyone at this panel, and I wish everyone still a good Intersolar show. It's the last day. Please be efficient and have fun.